Hello, I'm Stefan Graeber. I'm the project leader for LXD, and today I'd like to go over building a home lab using LXD cluster and some Raspberry Pis. So as you can see on the screen, I've got 3 Raspberry Pis here, all of which are Raspberry Pi 4s, 8 gigs, 8 gig models. So that means they're quad-core CPU, as you can see here. So quad-core ARM64 CPU with 8 gigs of RAM. And they cost about $75 a piece, on top of which you should plan on adding USB power supply cost, a small micro SD card for the operating system, and then I would very strongly recommend a fast USB 3.1 mass storage device, whether it's like a USB SSD or fast or like an external drive or something. The built-in SD card is quite slow and doesn't really perform well for running something like a bunch of LXD instances like's gonna be happening here. All of those are running Ubuntu 20.04 server, and that comes pre-installed with LXD, in this case LXD 4.7. As I've done in past videos, I'm gonna be refreshing that to our latest monthly release. This is gonna potentially fail a little bit today. It takes a little while, a few tries. That's because the Snap Store is having a bit of a bad couple of days right now. So there we go. Basically what's going on is that we're pushing a big update of LXD 4.0 right now, and that's been swamping the Snap Store a fair bit. So the LXD Snap is currently throttled a little bit, and so only a percentage of requests are actually being served at any given time. All right, so it looks like I managed to get all 3 to talk to the store and download latest LXD 4.18. So just clear the screen on all of those, and the last one is almost done. And here we go. Okay, so first thing first, it's gonna be, well, actually we should take a look at the list of network devices. That's gonna be useful during setup. Okay, so useful information to keep around. Then run LXD init to configure LXD, and that will let us create the cluster, configure initial storage and network, then can make sure that this first Raspberry Pi behaves as expected, and then cluster the other 2 into it. So let's set up clustering. IP address is fine. Not joining an existing cluster, we're creating a new one. Let's call it RPi01 for that particular server. No need for password authentication on a cluster. There's a new token-based cluster authentication that will be used instead. Now, creating local storage. Let's use ZFS. Creating a new pool. In my case, I don't. The entire install of Ubuntu has been done directly on a fast USB-based storage, so I can't feed it an entire drive to put LXD storage onto. But if you did install Ubuntu on the built-in SD card, and you've got an entire drive now available for whatever you want, then I would strongly recommend you say yes to this, and then you select the external drive for LXD storage. So in my case, I'm just gonna keep the default, which is a loop-based pool on the root file system. No need for external storage, no need for mass integration. That question is asking whether we want to use an existing bridge or host interface. And for this one, I'm gonna say yes. The reason for that is this is a home lab. We've got those 3 Raspberry Pis going to be clustered together. The instances that they run, we'd like them to be directly on the same network as everything else in the house, so that it's easy to connect to those instances from any laptop, desktop, mobile phone, whatever that's on the same network. That's not possible with a normal network bridge, but we can tell LXD to bind to the physical network interface and then use that. So that's why I was listing the network interfaces earlier. Now I've got that very long name for the network interface on this Raspberry Pi. I can select that, keep the default for the rest, which is just updating images in the background, and no need to see the YAML output. And that's it for the installation. So now we've got LXD 418 installed with a cluster initialized, but there's just one machine in it. So that's what you can see in cluster list. You can see just the one system inside it. Now let's try running a couple of instances. So let's do an Alpine container. Okay. I guess we can do Arch Linux too. So let's do Alpine and Arch Linux containers. So just downloading the image, unpacking it, creating the ZFS dataset for them, and then creating the instance from there. The Arch Linux image being obviously quite a bit larger than Alpine. And okay, so it's unpacked and it's created now. And container is starting. Come on. Here we go. Okay, so now there are two containers running. The first one got an IP address on the network already. The second one hasn't yet, but it's about to. And there we go. It's got IPv4, IPv6 configured. We go, say, inside the Arch Linux container here. Can make sure it's got access to the internet, and it does. That's all good. All right, so that's our first Raspberry Pi functional. It's running two containers right now. Network connectivity and everything looks good. So now we can add the other two. The way to do that's going to be doing LXC cluster add and then name. So RPi02 and RPi03. That gives us join tokens that we can then use through LXD init on both of those. So I'm running LXD init on both of them. And then saying yes to clustering. This time saying that we're joining a cluster. We do have a join token. So this is for us RPi02. I need to take this token and paste it here. It tells me that any data that's in that LXD is going to be lost. It's completely blank, so that's fine. Asking for the size of the local storage pool, we'll just keep the default source. Those the source you would need to answer with the right block device if you decided to use an external disk or partition. But because I'm just using the loop back option, I don't need to select anything. And this one should be done. And then I'm going to be doing the exact same thing with the RPi03 over there. So joining cluster, do you have a join token? Yes, I do. Copying that in. Deleting all data and then answering to use the default to those three questions. And it's going to join as well. At which point, just waiting for the join to be complete. There we go. LXC cluster list now shows the three machines. So we see RPi01, 02, 03. They're all online, functional. Everything is good. Now that the cluster is assembled, in many cases, especially for a home lab, you're not going to be dealing with those machines by SSHing to the individual Raspberry Pis. You're going to want to instead work from your laptop or desktop machine or anything. So for that, you need to set a trust password that's going to be used to authenticate remote clients. So I'm going to be doing set core trust password and just call that demo. Okay, and with that done, I can now move to my laptop. Actually, I just need to keep in mind what the IP address is of one of them. Okay, so 172.17.16.12 in this case. And then move onto my laptop here. And I can do remote add, give it a name, I just call it RPi. And then the IP address. Validate the fingerprint, enter the password. Okay, and then for convenience, you can switch the command line clients to only interacting with that remote. So I'm doing remote switch RPi. There we go. And now if I list what's running, with the two containers. So that's all good. Now I'm gonna be spawning a couple of things. We just start the second terminal here. There we go. So on the first one, I'm gonna be asking for a Ubuntu 20.04 cloud, and we'll make that a virtual machine. So that's gonna take a little while because the virtual machine image is quite large and takes a while to unpack on Raspberry Pis. So I'm just gonna let that one happen while also launching a Ubuntu 20.04 container. So just call that Ubuntu and launch. One thing you might be wondering is now you've got 3 Raspberry Pis, where are things gonna go? So what LXD does out of the box is it picks whichever system has the fewest instances and will place new instances onto that. This can be overridden. So you can say we wanted, spawning another terminal here, say we wanted another Alpine container and we want it on the same RPi01. So first let's just do one where I don't tell it where I want it. So just do create a new container, call it Alpine1. So that's being done. And now if we look at where things are, here Alpine1 ended up on RPi03. But I wanted it, if I want it specifically on RPi01, you can do -- target and then say, actually, I'd like a new container called Alpine2 running on RPi01. And this time around, we're gonna see that Alpine2 is now on RPi01. And because they're all connected to the physical network, it doesn't matter where the instances are, it just works. They can talk, all of the instances can talk to each other. So I can take that Ubuntu container, which is running on RPi03, and I can ping, say, the IP address of the first Alpine container, and that's working perfectly fine. They're all on the same network. It also means that from my laptop here, I can also directly reach to those instances because they're running on the same physical network. The virtual machine is still being set up, so waiting for that one to come online. But yeah, those Raspberry Pis are quite incredible, especially for the cost, like $75 you get 4 cores, 8 gigs of RAM, and it is virtual machine capable. You can run full-fledged virtual machines of a variety of Linux distributions. And in theory, even Windows 10, like there's a Windows 10 ARM64 build that can work. It's not gonna be the fastest ever, but you can run hundreds of containers and a few virtual machines on this kind of hardware and it will do perfectly fine. So other kind of things you get in a cluster, LXD cluster list gets you the state of everything of the cluster servers themselves. So we can see RPi01, 02, 03 here. They're all online and fully operational. The failure domain can be modified if, say, you had the 2 different power feed and like 2 of the Raspberry Pis on one power feed and another one is on the other power feed. You can mention that as part of failure domains, which might help with database high availability on LXD side to make sure we never get a majority of database servers running within the same failure domain effectively. So an example of how to do that would be you can do edit RPi01, you can do failure domain, let's say PDU1, and description would be top board, say if you had them in a stack. Okay, and if you refresh, you can see the description and the failure domain has been updated. So I can do it again on 2. So say it's on the same PDU, so PDU1. This one would be the middle board, I guess. And then 03, let's say this one is on PDU2 and bottom. Oops, can't type today. There we go. Okay, and that's the descriptions and failure domains updated on all 3. LXD clustering provides a high availability API and database so long as you run at least 3 servers. You can run less than that, but if you do, then only the initial one will run a database and the rest are the other one is just gonna act as a client effectively. When you've got 3, then we've got effectively enough to have quorum, and that means the database is now properly distributed on all 3, and one of them can go down and the database will remain fully functional from the other 2. You can, if you go up to 5, then number 4 and 5 effectively will act as a standby database member, meaning they do get all the data, but they don't slow down as far as voting to actually get a change done. And past 5, anything on top of that is just gonna be effectively a client. It won't store a copy of the database. Now those roles actually move around dynamically. So if you've got a larger cluster of say 5 or more servers, you'll see that some will have the database column set to yes and some won't. And that's going to be a one way to figure out exactly what the roles are at any given time. But it's all done dynamically. As machines go offline, whether planned or unplanned, the roles will be shifting automatically. So there's really no need to think about like an external database or configuration or any of that. LXD just takes care of it all automatically. Alrighty, so virtual machine has now started. So if we look at the full list of instances, now we can see there's an Ubuntu VM running on RPi02. I could launch a second one of those still on the same server. So let's do again RPi02. I'm doing the same server again just because that's going to be significantly faster. You saw how long it took to create the initial VM. Creating a second one took just a few seconds. That's because the ZFS dataset and all of that stuff only needs to be created and imported once. Once that's done, then it's really fast. Another thing that can be done with clusters is sometimes you do need to do maintenance and you need to move the instances around. Live migration is supported by LXD for containers, but it's not been really reliable and we don't enable it by default, nor would we really recommend it. For virtual machines, it's still a work in progress, so we don't actually have it yet, but we do have non-live, effectively cold migration working, and that can be used to perform effectively node evacuations. So say we've got RPi03 here and we need to shut it down because we need to update the kernel or we need to do something like that. What we can do is LXD cluster evacuate RPi03. It's going to ask to confirm that yes, we want to evacuate it. So yeah. And then what that will do is instruct LXD to shut down the instances, and then depending on configuration, either move them or just keep them down. In this particular instance, because we are attaching directly onto the physical network, LXD can't be completely sure that the other members of the other servers in the cluster will provide the exact same networking. So it's taking the safe way and not actually moving the instances, instead just shutting them down so that you can do maintenance and then bring them back up. So when you do LXD cluster restore, we'll see those 2 instances will just be started back up. So that works, but it's not ideal. It goes, like, if you're thinking long, that you're going to be doing quite a bit of maintenance, that might be downtime you're not fine with. There is a way to work around, to change the behavior, to instead tell LXD that I know what I'm doing. All the servers are actually identical. You can go ahead and move things. It's fine. And that's through a configuration key. So LXD profile sets default cluster dot evacuate, and then the option in this case is move. Migrate, sorry. Okay, it's just complaining that settings can't be changed live on virtual machines. That's perfectly harmless. The configuration has been done. So if you go look at profile, show default, we can now see that the default configuration does have cluster evacuate set to migrate. And let's do the evacuation again. Now on evacuate rpi03. So let's do that. And this time what will happen is that it's gonna stop them, but then instead of just keeping them stopped, they will be moved to another Raspberry Pi, like whichever has the fewest instances at the time. And then the instances started back up on that. And that's done. So our two instances were here, rpi03, we had Alpine and Ubuntu were running on it. Now if we look again at the list, we see that everything is running, but the Alpine instance is on rpi01, the Ubuntu instance is also on rpi01. And cluster list shows that rpi03 is currently evacuated and available due to maintenance. So that means I cannot create anything on there. Like say I wanted to do another Alpine container. So Alpine 3, I guess at this point. And I do target rpi03. Like this is gonna tell me that node is evacuated, you can't create anything new. And now if I do cluster restore rpi03, it's gonna track down what instances used to be on it, will shut them down, move them back, start them back up. That's what we're seeing right now. So it's stopping the Ubuntu instance, then we'll say it's gonna be migrating it again, and then starting it back up. And all of that stuff is done using using some delays, so that if something an instance takes too long to shut down or to move or any of that, it will eventually just force the shutdown, move it, start it back up, and that's all configurable. And now if we look, Alpine 01 is back. No, Alpine is there. What was? Oh, Alpine 1 is back on rpi03, and Ubuntu is back on rpi03. So we're back to where we were, and cluster list is gonna be all clean. So that's pretty much it. That was really a view, like a quick demo of assembling a cluster on hardware that you can get at home for just a few $100, running a variety of Linux distributions, both in containers and virtual machines, across that cluster, accessing it from another system on the network, and like showing some of the more complex things you can do, like the failure domains and evacuating systems as maintenance is needed. Hopefully that was a good demonstration of just how easy using LXD cluster can be, and we'll get some of you interested in trying it for yourself. If you've got any questions, use the comment section or use our community forum. We're always happy to help, and we're really quite keen on having more people use both LXD clustering, LXD virtual machines, and also using LXD on embedded ARM platforms like the Raspberry Pi. Thanks.